This is TWIS. This Week in Science, episode number 861, recorded on Wednesday, February 2nd, 2022. Why is one the loneliest number? Hey everyone, I'm Dr. Kiki, and tonight on the show, I will fill your head with Trojans, guts, and T cells. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Disclaimer, disclaimer, disclaimer. Like the ever-changing surface of the sea, so goes human history. It's strange, we search for stability when what is optimal is always shifting. The wind blows and creates ripples across the sands of time, yet humans search for a cave where they will be protected from the elements, where their dancing shadows will be forever etched against the walls. We ache for safety, security, certainty. And This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you. Welcome, everyone, to another episode of This Week in Science. And yes, you may have noticed that it's only my voice so far. I'm Dr. Kiki, and tonight I am the only host of this show. Justin is taking care of a sleepless baby, and Blair is really not feeling well. So, unfortunately, it was a last-minute maneuver, and I have no co-hosts, but I'm here because we always try and bring you This Week in Science when we have said that we're going to bring you This Week in Science. So thank you so much for joining us for another week of science, discovery, curiosity, a little bit of uncertainty, I hope, and we will dig in to the science together. On this week's show, I have science news. I've brought you stories about Trojan asteroids, a stronger plastic, capybara guts, alcoholic monkeys, and our weird vision. Yes, we have not weird visions, but we have weird vision. Yes, our eyes and our brains and the way they work is very odd, and we will get to that toward the end of the show. As we jump in tonight, I do want to remind you that if you have not yet subscribed to This Week in Science, you can do so. Look for TWIS or This Week in Science on your favorite podcast platform. We also stream weekly and are available on YouTube, Facebook, and Twitch. You can find us as TWIS Science, TWISCIENCE, on Twitch, Twitter, and Instagram. But if all these things are hard to remember, just go to twis.org. That's our website for more information. Wow, it really seems like the front part of the show goes so much faster when I'm not talking to anybody else. It's just me and you, everyone. Are you ready? Are you ready for all of the science news? Okay, let's jump in to the stories that I brought this week. This week, we have news of a second Trojan asteroid sharing Earth's orbit. That's right. There are Trojan asteroids around many planets in our solar system, and we've even sent Lucy, a craft or it's a mission that will be investigating the Trojan asteroids, Trojan moons around Jupiter. And we have our own, which is pretty cool. This particular space rock exists at the L5 Lagrange point. It's one of those kind of weird gravitational dwell points where everything's kind of balanced out and there's not as much push or pull going on. And so within this L5 region, there is 2020 XL5, and 2020 XL5 is about 1 kilometer and a half wide. It's over a kilometer wide. And they've just reported, researchers out of the University of Barcelona and their colleagues, which is an international team, but the observations were made from an Earth-based telescope that is located down. They've looked at used several Earth-based telescopes actually in order to make the observations of this Earth Trojan, published their confirmation in Nature Communications. It's pretty exciting because when you think of what a planet is, you think of a planet as having completely cleared its orbit. And now we have the moon, which is right near us, and we can see it, and it shares the orbit with it. It is tracking with us. It's the moon is trapped in our gravity and is basically, even though it wants to pull away, it's inching away, and we will eventually lose the moon someday. Not anytime soon, though. So if you have youngsters who are listening, and you can ensure them that there's no problems with the moon. They'll be able to look up and see the moon for, hundreds, thousands of years to come. And we take that for granted. And then we consider there are asteroids, but we never really think, oh, we've got other bodies sharing our orbit. And so these Trojan asteroids, the first one having been discovered back in 2010 in the L4 Lagrange point. And it's just very exciting to know that we're not alone in our rockiness in our orbit. This particular rock, 2020, what is it? What did I call it? 2020 XL5. It sounds like a car, like it's going to be some kind of a model of a BMW or something. This 2020 XL5, it is going to be perturbed by other gravitational forces and eventually make its way out of our orbit in about 4,000 years. So perhaps we will be seeing it someday. And I did want to bring another space story, just super quick, because this is kind of my trying to keep track of all those predictions that we made at the beginning of the year in our prediction show. I said that the SLS and the Artemis mission might not make it this year. Well, Artemis has officially been postponed again. They haven't given it a launch date. They say they're looking at dates for April or May, March or April, May time to look at launching Artemis 1, which relies on the SLS, which isn't going to be tested until March itself. So the fact that they have pushed it back, haven't given it a particular launch date, I think they're giving themselves wiggle room to continue to push that mission back. We'll see. Will the massive SLS, that space launch vehicle, actually get things into space? Will we go to the moon? Will NASA take us there? Yeah, we still have to find all that out, but I don't know. So far, my prediction, I think, is it's staying on track. So we're going to keep track. I will keep track of that. You can maybe help me keep track of it during the year. John Hogan, I too would like to see a launch in person. I have never seen a space launch in person. The timing and the locations and distance from where I've been have never made it very easy. But with the number of space launches that we have now with regularity, and those numbers are increasing now that the private commercial space industry has ramped up, I think we're going to see many more launches, and all of us will have more opportunities to get ourselves, perhaps more opportunities to see some of these massive, the massive proof of our human technological ability. Welcome, everybody. Okay, let's keep moving forward in the science. Beyond our Trojan asteroids, beyond the uncrewed Artemis mission, let's talk about fake photosynthesis. Well, not really fake photosynthesis. It's artificial leaves. That's what we want to talk about. We want to talk about carbon capture using artificial leaves. Researchers have developed a system in which they have basically created they're using wet and dry chambers, and they're using oxygen and hydrocarbons and pH to enable the transfer of, or the isolation of, carbon dioxide out of regular air. So this could be the kind of thing that would be used in flue gases in industry, or it could potentially be used in just, I'm imagining this as something that would be maybe a small size that you could have in your home to capture carbon dioxide from your own home, maybe powered by solar cells. So you have solar power powering this this new artificial leaf system, which is very modular. They say it's about the size of a backpack. And you could isolate carbon dioxide from the atmosphere within your home. And it could be tapped into a seltzer fountain in your kitchen, or in your in your wet bar. Yeah, I know. I have ideas and thoughts about very silly things sometimes. But these UIC College of Engineering scientists, they've pretty much distilled down this new method that allows the cost of carbon capture to be significantly decreased. The materials they're using, which is a very basic basic electrochemical membrane that allows the transfer of the molecules to get across from the dry side to the wet side across the electrodes, allows the concentration of carbon dioxide to happen in such a way and in such efficiency that they're estimating it would be about $145 per ton of carbon dioxide, which at this point is about, for most carbon capture technologies, they're looking at about $600. And they say to be competitive and to really make this kind of technology, carbon capture technology, start to work, ideally, we would be getting down under $200. That's what the United States government wants us to get. But to really work on our atmosphere and drawing down carbon, we need to get to a price point of about $50 to $60 per metric ton of carbon dioxide being removed from the air. But this is a very simple solution, and they say it only, for their backpack-sized module, it uses about the same amount of electricity as a light bulb. So it's not incredibly energy intensive either. It just needs a bit of electrical charge to charge the membrane that's in the middle of the unit. So anyway, yeah, carbon capture. Basically, I mean, I'm really imagining these things. Perhaps maybe not on every house, but this could be the kind of setup that would be on hotels, or maybe you put them in hospitals, or, yes, in the flues, in the in industrial applications where they capture those mixed gases that are coming out, but are able to isolate the carbon dioxide, and which is such one of the big problems, that isolation is actually being able to do efficient isolation in an easy, price-effective way. This is what we're looking for, and this seems like a really great solution. So we will see where it will go. And no, JG, I am not telling you that you can turn wine into champagne, but you can turn wine into champagne if you have, if you had carbon dioxide seltzer machine in your house. White wine, I wouldn't recommend doing that with red wine. It might not taste as good. But yes, I've actually done that with a nice bottle of rosé. Yeah. When lacking your rosé bubbly, go straight to your soda fountain. All right, let's move forward from this one bit of technology to another fun piece of technology that I thought was kind of neat this week. Researchers at MIT have developed a new, thin, strong plastic polymer. Yeah. We need more plastic, like I need a hole in my head kind of it might be the thought that's coming into your head at this moment in time. But this new polymer is made from monomers, single units of melamine. And you might know melamine from those acrylic plates. There are lots of lots of the hard acrylic dinnerware or cookware is melamine. And yes, it can be toxic if it is not treated correctly, but MIT chemical engineers have devised a way to get, instead of polymers, to create long string-like polymers, which is what normally happens. You have monomers and they attach like a chain and they create like a long string of spaghetti polymer, and you kind of mush all those things together and the polymers can create all sorts of different forms. But they have not yet been able to create single sheets. A two-dimensional sheet that's lightweight and strong has been something that chemical engineers have been trying to develop for a very long time. What ends up happening in most cases is that they start to grow the little sheet, but then a little monomer pops up in one direction or another, and then it blurbles out in the wrong direction, destroying the integrity of a single two-dimensional sheet of polymer. So now they have devised this way. They've published in Nature this week their methodology for creating this melamine two-dimensional flat polymer sheet, which they say is as strong as steel, but incredibly lightweight. So this could create new coatings for automobiles. This could create new shells for computers. It could, the applications for this kind of a moldable polymer that's very strong, and as long as it's not brittle like steel can be in some cases, it can be incredibly useful. So they've got these sheets, but once again, melamine, it's toxic. So are we just adding more toxic stuff to the environment if you can't figure out what another thing? And plastic, do we really need more plastic? Can we start figuring out other things that are more sustainable yet? I mean, it's not the 60s anymore, anyone. Well, two-dimensional, JG, and when I say two-dimensional, I mean in a very flat sense where it's got an X and a Y axis, as opposed to XYZ axes where you would think of it being more of a cube or a sphere. This is a single molecular layer that can spread out and be like a flat sheet of paper, which, yes, if you're really cutting hairs, that fine, splitting hairs, it is three-dimensional, but yes. Yes, I will agree with you on that one. Moving on from melamine polymers, let's talk about microbes. Who out there loves microbes? Have we learned to love microbes yet? I do love microbes. We don't think of them as our friends all the time, but indeed they are. And they're everywhere in this world. Some researchers just published their work looking into the microbial world to look for a particular JG. Yes, both love and hate. Love and hate microbes. Yes, Ashley. You love some of them, not all of them, but yes. We don't like the little viruses that make us sick, but we love the phages that like to attack the bacteria that make us sick. There's so many that we love. We love the bacteria that are in our yogurts, that are in our pickles, the things that give us the good food. No, let's not be mad at microbes. Let's look at them as the wonderful wild world that they are. Anyway, these researchers were looking for a particular capability that they found in a certain strain of bacteria that had been easily grown in their laboratory that they had been looking at for a really long time. And these bacteria that they had discovered were able to, and this is a quote unquote, breathe rocks. And so what I mean by breathe rocks? Well, the microbes can establish an electrical connection. So they use what they call EET. This is not ET, it's EET, extracellular electron transfer. So across their cellular membrane, the bacteria are able to transfer electrons. And usually this has something to do with, say, a proton pump or some kind of pore in the membrane that allows things to pass one direction or another. And so there's a trade-off of energy. And electrons in this breathing, this respiration, they bring in electrons, which power their metabolism. And so initially they were just like, wow, we've got these bacteria, Shawonella onidensis. Woo, one of the first EET capable organisms. They looked at it in the lab, they had it in the lab for a long time, and they were like, oh, nobody else is going to have this skill. This is super special, this EET-ness. Well, they did, as scientists do, they had to delve in to the microbial world and really take a look around. And oh yeah, it's everywhere. And in fact, microbes are sharing it with each other through horizontal gene transfer, which is the trading of genes back and forth that has nothing to do with reproduction. They just go, it's like playing cards, and they're like, go fish. Oh, okay, I'd like to take that one out of your pile. And these genes get swapped between different bacterial species. And so they've found that across the bacterial environments, different bacterial species are capable of extracellular electron transfer, EET, this breathing of material in the environment. And what they believe is that the bacteria, as they gain these genes, they probably make adaptations so that they can specifically use EET in whichever environment they're in to take advantage of the resources that exist where they are so that they can live in the most efficient, effective way possible, which is what we all want to do, right? I'm going to take advantage of what I've got here. Ooh, I've got a new tool in my tool chest. Oh yeah. But I can adapt it a little bit and make it work. Yeah. So the thing that comes from this, though, is when you think of the bacterial world and how bacteria have existed for millennia longer than other life forms, the more complex, quote unquote, complex life forms, such as humans, mammals, etc. Microbes have covered the earth, and we think of ourselves as amazing architects, but bacteria have formed the earth as much, even more so than we have. Bacteria have led to the oxygen that we breathe. Bacteria have altered the surfaces of the planet throughout its evolution as long as life has been living. So our planet is a form and function of the life that is on it, which is really very, very cool. Okay, no more microbes. Are you ready for capybaras, the world's largest rodent? We love capybaras, don't we? Capybaras are so cute and they're just these gentle grass-eating rodents that are massive. Seriously, capybaras. Some people have capybaras as pets. Other people think capybaras could be raised and used as a food source. I'm not of the eating capybara persuasion, but capybaras, how do they eat? How do they digest what they digest? Well, of course, researchers have been fascinated by the way that capybaras digest their food. And oh, how do they do it? With the help of microbes, just like us. That's right. Oh, the microbes. The microbes give the capybaras the ability to digest the grasses that they eat. And so when we think about grass-eating organisms, normally we'll think about cows or deer, the foregut fermenters. Maybe they have multiple stomachs. Maybe they have multiple chambers. Maybe they digest early in the intestinal region. foregut fermenters are one kind of grass eater. They have bacteria that allow them to break down the cellulose and the lignin in all of the food that they're eating. Capybaras, being rodents, they do it differently. And so they are what are called hindgut fermenters. That's right. They ferment in their cecum. That's their large intestine. So capybaras, nice big rodents, they've got a bunch of gas in their guts. And it's all because of the microbes that live there. And according to this new study that is out in Nature Communications, I think this week. Yeah, Nature Communications. They're saying their title is Gut Microbiome of the Largest Living Rodent Harbors Unprecedented Enzymatic Systems to Degrade Plant Polysaccharides. And I just wanted to share with you a quote that I pulled from the paper because the author of this paper is a brilliant wordsmith. Yes, the science gets across and it's done very well, but the words and the way they're melded together, they're poetry. So let me just read this to you here. These findings highlight the potential of the capybara gut microbiome as a reservoir of uncharted enzymatic systems for carbohydrate processing, and thereby expanding our current understanding of gut microbial strategies from hindgut fermenters to overcome the plant cell wall recalcitrance, which might be instrumental to foster the development of value-added products from lignocellulosic agro-industrial materials. I honestly love scientific writing when it's done so well, using the exact words that are necessary to explain. So, what is this saying? In the gut of the capybara, they have found microbes that have really cool enzymes that they haven't really considered before, which could potentially be used to help maybe with biogas development or other materials that come from industrial breakdown of plant material. So from the capybara gut to the future of our sustainable energy program, perhaps. I love capybaras. Fada, what have you done there? It's not capybara, it's a kookaburra, but I do appreciate it. Capybara sits in the old gum tree, merry, merry king of the bushes. He laugh, capybara, let dance, capybara, gay your life must be. But it's a kookaburra. The capybara would just be sitting there chewing the grass because they're so mellow and they just want to chew the grass. Oh, these little capybaras. So this was my ode to Blair's Animal Corner, talking about the guts of the capybaras. Does it take guts? Do I need to show you a picture of a capybara? I should have shown you a picture of a capybara. These cute little capybaras. These wonderful capybaras with their serious faces. Yes, their serious faces. They look like giant guinea pigs. And they're very friendly and maybe I will move to Brazil and start a capybara farm. That might be a nice way to go into my old age happily with a capybara farm. Enzymes from the capybara gut. Oh my goodness. Thank you for joining me for this episode of This Week in Science. I'm so glad to be here talking with you about science, and I'm glad that you decided to spend this hour with me. If you enjoy it, please share it with a friend. Okay, let's move on from capybaras to COVID. Whoa, what a transition. Okay, so most everyone is aware of Omicron, the latest variant of COVID-19, SARS-CoV-2 virus at this point in time. Omicron has surprised scientists by having a related sister called BA2. The original Omicron strand is called BA1. Some researchers think, however, that the BA2 strand shouldn't necessarily be considered exactly the same as Omicron because they found that they have differences. One of the interesting differences that is concerning is the fact that BA2 is more transmissible than BA1. So BA2 has been spreading rapidly in areas and possibly gaining dominance against Omicron. Now, the original Omicron, BA1, has a lot of mutations that have allowed it to escape from vaccine coverage. So the vaccine efficacy has decreased. 3 doses of the mRNA vaccines have been recommended to this point in time to enable the antibodies that normally battle in your primary immune system response to be able to fight off the infection. Well, BA1 kind of gets around that a little bit, so we have a lot more breakthrough infections of BA1. BA2, however, is a little bit more similar to the original Delta strain. So a lot of the mutations that are there in BA1 that allow it to escape vaccines are not there in BA2. So BA2 gets hit by those antibodies a lot harder. So even though it's more transmissible, it is getting captured and controlled by vaccines a lot more easily. So what this means is more unvaccinated people are getting the BA2 strain and spreading it to each other, whereas people who are vaccinated are more likely to be getting sick with the BA1 version. So all that said, antibodies are very important. BA1 is battling those antibodies and trying to avoid them. BA2, less able to avoid the antibodies. But a new study is out showing that T cells, if you've been vaccinated, you have the coverage. The vaccines are allowing coverage from alpha to Omicron. All of them, the T cells recognize and respond to. So at this point in time, that does explain why there is less severe disease with Omicron than there has been previously, especially as more and more people have been infected through time. So it's very exciting in that respect. And then additionally, there's been some recent work looking at predictors of long COVID, and a new study has been published in Cell that reports a number of predictors for individuals who will potentially come down with long COVID. And so it is great in one way because it's going to make it easier to predict long COVID occurrence and potentially offset that long COVID occurrence. Some of the things that they've been looking at there is the reactivation of latent viruses during initial infection, and the things that we're talking about in that respect are like Epstein-Barr virus, viremia. There's also issues with people who have type 2 diabetes. If there are high levels of SARS-CoV-2 RNA antibodies, if there's lots of high levels of the virus and antibodies in the blood at the time of diagnosis, that is also very likely to lead to long COVID. So this more severe disease early on. Other things that are related are specific autoantibodies that they can measure for. So the detectability is important. It may lead to, like I said, the understanding of the emergence of more chronic conditions after COVID infection, and maybe treatments before that does set in. JG, you're saying you want to get more boosters. Well, if you've had your normal shot, had one booster, unless you are immunocompromised, it is not recommended that you get another booster shot. That isn't recommended at this point in time. They probably will be releasing that kind of thing in about 6 to 12 months. Oh, Kai just lost another tooth, everybody.
Yay, I've lost 4 teeth in the past year.
Woohoo! That's science. That is the most gruesome human biology.
It
It's
was
gruesome.
actually kind of painful. I blood.
Yeah. Okay. Did you pull it out?
Yeah, I was messing around with it. I just
Congratulations.
yeah,
Tooth Fairy's coming tonight.
But there was a huge cut, so I started bleeding like crazy.
Uh-oh.
It's okay now.
Seriously, teeth are gruesome. Like they're like, "Ah," and like they push out. Like honestly, it is to me one of I love it. I love it. But it is one of the most gruesome processes that we have in our development as human beings. That's right. Take that, teeth. Woohoo. He's getting into the adult teeth here. It's very exciting. My baby's growing up. Oh my goodness. Oh my goodness. Beej, yes, your comment, the whole thing about the virus is it is adept at evading our immune systems from the very beginning. And that's true. It's also the way that the actual cellular infection happens. There are a couple of mechanisms by which SARS-CoV-2 accesses the cells. And the difference between the alpha through delta, which affect the lungs a lot more, and why we have had much more respiratory symptoms and disease from from those variants of SARS-CoV-2 infection than Omicron, is that Omicron actually the way that it infects the cells might make it less able to cause the disease in the lungs. And so that's why we're seeing more sinus and throat kind of symptoms coming through. Researchers are learning, and like I said last week, we don't know where it's going to end. We don't know what is going to happen in the long run as we shift from the pandemic to endemic. But remember that diseases like malaria are considered endemic in other areas of the world. So endemicity does not mean not dangerous. And that is something that we just do need to consider as we look forward into the future of living with COVID. Right, JG? No one cheers when we lose teeth anymore. It's like, can I go back to the dentist and put this back in again? Yeah, Kevin. I think many of us have forgotten what normal was. And in fact, it's good to not go back to normal because normal is what got us this pandemic. And if we go back to normal, it's very likely that it will lead to more pandemics that are hopefully, would likely be as devastating as this one has been, maybe even more. So can we move forward to a new normal in which we live sustainably and are able to develop a public health system that works in a way to prevent future pandemics from affecting us as much? I mean, that's what you hope. Can we learn from our mistakes? Huh, humans? Learning is good. Learning. We like the learnings. Yes. Oh my, oh my. This is This Week in Science. Thank you so much for joining me for this episode. If you enjoy the show every week, maybe consider supporting us as a Patreon donor. If you head over to twist.org, you can click on the Patreon link, and that takes you to our little community over on Patreon, where you can choose your level of support. $10 and more will get you thanked by name at the end of the show. We have lots of other thank yous, and there are gifts that are sent out by Patreon periodically. We do hope that the gift of TWIS is enough for you, though. Thank you for your support. We really can't do this without you. All right. I only have a few more stories here. And as I sit here and drink my water, I'm not thinking about a glass of wine after this show is over. I'm not thinking about a beer or whiskey. One whiskey. Wait, how does that? That song, I lost it. A whiskey, something, and a beer. I've totally lost it. Anyway, researchers have been trying to figure out how to get people to drink less alcohol, especially people who have problems with alcoholism. How do you reduce the cravings? How do you reduce alcohol consumption? And of course, they've done many, many experiments in mice. But what can we do in people? That's the fun one, right? Well, they still haven't done anything in people along these lines. Monkeys. Monkeys will definitely do the trick. Let's use monkeys. So, researchers published just yesterday in Cell Metabolism their study looking at vervet monkeys that had a strong preference for ethanol. That little alcoholic monkeys. There we go. And research had suggested for years that a particular hormone related to fibroblast growth factor. And there's a particular factor that's produced by the liver. There's a number of them that are produced, but this one particular growth factor, fibroblast growth factor 21, FGF21 specifically, has been implicated in control of metabolism, control of weight gain, weight loss, muscle wasting or atrophy, and also craving for protein in your diet or avoidance of sugars. And so this is over the years been it's been a hormone of interest, and they know that it affects the brain. They know it affects the dopaminergic system. They know it affects the nucleus accumbens, which is part of the brain that's in the reward pathway involved in sugar cravings and all that kind of stuff. And so these researchers were like, okay, we know that we have some of these pathways in the mice. We have done this work, and we know that if we give them FGF21, reduces alcohol cravings in mice. Is it going to work the same in the monkeys? Because, if it works in monkeys, it's much more likely to work in people. So they gave these vervet monkeys FGF21, and dun, 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 the monkeys consumed 50% less alcohol. They reduced their alcohol intake. Now, what I want to know that they did not look at, they didn't look at any other dietary factors, but since FGF21 mediated suppression of sugar intake usually happens with an increase in intake of protein, I wonder if these monkeys were like, I'll have the steak and eggs breakfast, please. Please. I don't know if that's what they were, if they wanted to increase their protein intake at all. But this is a hormone, a factor that is produced by your liver naturally. If you are not eating enough protein, FGF21 gets produced by the liver, and the liver goes, dudes, I don't like this. You need to eat more protein. And it kickstarts a pathway to get you consuming more protein so that you have less muscle wasting. It's also, and there's some interesting relationships they've found between ketogenic diets and fasting. And so it is very dietarily related. But in this particular case, they were able to show that it triggered suppressive neural circuits within the brain that led to suppression of activity in the nucleus accumbens. So suppression of that reward pathway. And so FGF21 potentially is something that can be used to reduce alcohol intake in people who would like to reduce their cravings a bit. But we haven't done any work in people unless we want to consider ourselves monkeys. We're not monkeys. We're not monkeys at all. Are related, but there needs to be more research before you start looking for those FGF21 supplements. And I already did a search, and there aren't any really. You can buy lab grade FGF21, so just don't even go looking. Gaurav Sharma, hamsters, some hamsters have a high alcohol capacity, probably genetically determined, and depending on their livers. Livers are the organs that help to clean the blood and to detoxify with the alcohol dehydrogenase and all the other stuff, the good stuff that goes on in the liver to clean up your blood. And I'm I'm guessing that they probably have a similar system involving FGF21 because this is a very conserved hormonal system involved in dietary intake. And it's not necessarily alcohol intake, but we do know that animals throughout history, if we became introduced to alcohol with fermenting fruits, probably somewhere way back in our family history, our evolutionary history. So, where we came from, where did we come from? We were eating little berries on the trees, and some of the little berries were fermented, and suddenly, oh, we're drinking alcohol sugars as opposed to just eating sugar. And our body had to deal with some of that, but it probably is linked in a similar pathway to control it. Yeah, and JG, yeah, I mean FGF21 or less impending doom. That would work as well. Oh my goodness. Oh, okay. Let's move from FGF21 suppressing. Oh, I had a whole picture as well. I keep forgetting it's me by myself, and so I keep forgetting to show off pretty pictures that we've got. Oh, that's a very tiny picture right there. Whoop, there we go. Let's make him bigger. There, you can see the liver and the FGF21 and the mice and the monkeys having beverages because somebody thought that would be funny. Enjoy the wine. Yes. Yes. But anyway, it's pretty interesting that we have these hormonal pathways from our liver to our brain that control what we want to put in our bodies, right? So that's a very fascinating process. It's all connected in there deeply. Okay, moving on. Two more stories. We don't want to talk about balanced diets. We want to talk about a mashup of our vision. Oh, yeah. So this story, I think, is super fun. And what I enjoy about it is the research that the scientists have embarked on. We're going to look at this wonderful video, visual instability here. Researchers who have just published their work are interested in how our brain gives us visual stability. So, we move around, and if you've ever tried to like take a video with your phone as you're walking and moving really quickly, you can see the way that things blur past, and your camera potentially has a hard time keeping up with the images that move past you as you move. How does our brain stabilize perception within our visual field? So, these researchers in this particular video, they're giving an example of how our visual field moves around. If you're looking through, say, a little tiny hole and trying to track your world through a little tiny straw, you're going to just be getting snapshots and very incoherent, unstable representations of the world around you, as opposed to the much larger. What they tested, they gave volunteers videos of time tracking the aging of an individual. So one side of the screen showed an individual aging over time, and the other side showed the individual just staying the same age. So they, through artificial intelligence, artificially aged a person over time. And when they asked people to let them know how old the person on the left side of the visual field was, everybody estimated the age as the age not where the video ended, but at a point prior to the end of the video. And so what they're hypothesizing is that our brain is pretty much procrastinating in how it tracks the world, and that our perception of the world is actually about 15 seconds behind what's actually going on. And it's a mashup that our brain has pretty much taken like all these bits and pieces, and mostly it liked the first instance, the first perspective it got, and it's like, oh, that's great. We're going to keep an eye on that. And so this is why it's so easy for something to change in your visual field and you didn't miss it entirely. Why we succumb to visual tricks so often is that our brain is like, no, we're just gonna, I like all these things and we're gonna dither. So if you're if you understand the idea of digital dithering, that is what our brain is doing. It is taking all the snapshots of even if you're just looking, not moving and just looking at the scene around you for a minute or so, your brain is taking constant pictures. But it doesn't need. Your brain's like, I'm lazy, nothing's changing. Why do I have to pay attention? And so it doesn't. And it gets lazy and it just goes, okay, we're going to cut and we're going to put it together here. We're going to mash that together. That's the same. Oh, that's the same. And then your perception is not actually keeping up with reality. So we're behind because our brains are lazy, which is, I think, it's just hilarious. Really? My brain, I want my brain to be on it. Why is my brain not on it? Why is your brain not on it? Well, because our brains like to conserve energy any way they can. And so your brain doesn't keep up with this movement of the aging and the change in the little features. Your brain is like, man, okay, general gestalt, that's good. And our perception likes to stabilize our chaos by biasing towards the past and what it knows to be more true or more reliable. It's pretty fun, right? It's a neat little trick. All right. My last story for the night is one that's kind of close to my heart because, I mean, I want to age gracefully, as hopefully many of us would like to try to do. And as you get older, and for those of you who are young and watching this, oh yeah, you've probably noticed the people who are older in your life complaining about aches and pains a little bit more as they get older. Maybe you too are starting to, oh, my aching back, ow. You wake up in the morning and you groan a little bit more at the pain. You wake up with random pains you didn't have when you went to sleep the night before. Researchers from the University of Portsmouth have done a study in which they examined 5,800 people age 50 or more, and they looked at them over 10 years. And over the 10 years, they wanted to determine how many of them, deteriorated in their physical state, how many started complaining more of pain, how many had chronic pain, how many were dealing with it, and what were the differences, what potentially made the difference in people who suffered from musculoskeletal pain as they aged at the end of the 10-year period. And what they found is that the people who worked out really hard are the ones who had the least aches and pains at the end of the 10-year period. So they examined the experience of chronic pain alongside gender, BMI, age, and wealth over this 10-year period. And it's high levels of physical activity that appeared to lower the risk of that musculoskeletal pain developing. Risk factors, definitely. And we've talked about social factors that are involved in this kind of thing in the past, being poor, being female, being overweight or obese. All independently are risk factors for suffering from musculoskeletal pain, according to their study. And we probably could have told her that. But they think from their study that their findings suggest if people want to avoid chronic pain, yeah, become wealthy. Don't be female. No, these are not the things that that they're suggesting, but it's not even just moderate exercise. And we talk about exercise levels, oh, it's just going for a walk, or yeah, you're exercising when you're vacuuming the house or doing dishes, you're standing up, you're not just sitting down, right? No, moderate exercises like light dancing, walking, stretching, gardening, these kinds of things were not even able to keep the pain away. It was high energy, vigorous physical activity that led to the differences. Yeah, so the idea is that it's not even just mild exercise. It's heavier exercise that you have to do, intense exercise to avoid the pain. So if you want to avoid the pain, go running, play tennis, tackle football. Wait, no, maybe not the tackle football. Soccer, do the headers. Maybe not that. I don't know. But more intense, probably not so intense that you are injuring yourself, but more intense exercise is probably better. And I'll say from my own experiences with back pain that the more I actually do work out and do exercises that support my musculoskeletal system, the better it makes me feel. And the less pain, aside from the workout pain I have. I wake up with fewer aches and pains. Yeah. Oh, yes, we have dark humor. I have dark humor as well. Dark humor, everyone. And yes, Ashley, you'll be golden as you age. Yeah, pain from minor injuries, not from sedentary lifestyle. Oh my goodness. I made it. I did it. Came to the end of the show with all of you. You stuck with me, and I really appreciate you being here for the science this week. And I want to thank all of you for enjoying the science, bringing your commentary, being a part of the TWIS family. Thank you for joining me once again. And for everyone out there, I guess it's time for me to say goodnight. Maybe I'll do a little bit of an after show with and talk with you all in the chat room about little things. We missed Blair and Justin this week, but they hopefully will be back next week. Justin, I'm guessing he's not going to be back right away because he has a newborn child. So we're not promising on that one. We'll see. I need backup plans for my backup plans moving forward. I hope you all enjoyed the show. Shout outs to Fada. Thank you for your help with social media and show notes. Gord, thank you for manning the chat room. Identity4, thanks for recording the show this week. Rachel, thank you for your editing and your assistance. And I would also really, really like to thank our Patreon sponsors. Thank you to Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazar, Ralphie Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Woody MS, Andre Bassett, Chris Wozniak, Dave Bunn, Begard Chefstad, Hal Snyder, Jonathan Stiles, aka Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Don Mundus, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredus 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Sean and Nina Lamb, John McKee, Greg Riley, Mark Hessenflod, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Grindley, Kevin Railsback, Rami Day, Flying Out, Christopher Dreyer, RDM, Greg Briggs, John Atwood, Hey, Arizona, support Aaron Lieberman for governor, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Mallory Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloths, Jim DePoe, Sarah Chavis, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele, Ulysses Adkins, and Jason Roberts. Thank you all for your support of TWIS on Patreon. And if you would like to support TWIS on Patreon, head on over to twis.org and click on that Patreon link. On next week's show, Hopefully the hosts will be back. We will have another show of This Week in Science for next week in science, and I do hope to see you then. We will be broadcasting from our YouTube, Facebook, Twitch, and twist.live.org is where you can find links to all those things. Want to listen to us as a podcast? Oh, yes, you do. If you're not subscribed, you can find This Week in Science wherever podcasts are found. And if you enjoyed the show, get your friends to subscribe too. For more information on anything you've heard here today, show notes and links to the stories will be available on our website, twist.org. And you can also sign up for our newsletter that may come out again someday. I have a newsletter too, personally, just me. I'm doing one now, so let me know. I'll put a link out somewhere so you can subscribe to my newsletter. For information on anything you've heard here today, show notes are going to be available and links to stories will be available on our website, twist.org. I already said that. You can contact us directly. Email me, Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, Blair Baz at twist.org. Put TWIS in the subject line so your email doesn't get spam filtered into the hind gut of a capybara, where its wonderful, beautiful, amazing enzymatic activity will filter it into oblivion. You can also ping us on Twitter, where we are at Twist Science. I'm at Dr. Kiki. We have at Jacksonfly and at Blair's Menagerie. We do love your feedback. So if there is a topic you'd like us to cover or address or a suggestion for an interview, please let us know. We'll be back again next week. And we do hope that you will join us for more great science news. If you learned anything from the show, remember, it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. Science.